Hello, welcome to the solution of practice assignment 5 of stats 2. Let's get on with it. So the first question, they've given a random variable x as Bernoulli 0.6. Let y is equal to y given x is equal to 0 is exponential 1, and y given x is equal to 1 is given exponential 3. So what is the marginal of y? So how to find out the marginal of y? So it is nothing but, so we have to y of y is equal to sigma, you have to sum over x, right, belongs to tx, and px of x into fy of, so fy given x equal to some random x, right? So they've given two different things. Since this is a Bernoulli, x will take only value 0 and 1, right? So the first thing, for let's take it for 1, so px of 1 into fy of x equal to 1 of y plus, now let's take as 0 px of 0 into fy given x equal to 0 of any value of y. So what is the answer here? So this probability of success is 0.6 into, what is this function? So that is nothing but exponential of 3, right? So that is 3 e to the power of minus 3y plus probability of failure is 0.4 into, so this is exponential 1, that is e to the power of minus y. So this is nothing but 1.8 e to the power of minus 3y plus 0.4 into e to the power of minus y, so which is the last option. So second question, let x is a uniform 1 to 3, y given x is equal to 1 is exponential 1, and y given x equal to 2 is exponential 2, and y given x equal to 3 is normal 0,4. So what is the marginal of y? Again, similarly, we have to solve this for marginal of y, so which is nothing but we have to multiply the probability with this particular functions, right? So that is nothing but px of, let's start with 1, px of 1 is nothing but fy given x equal to 1 of y plus px of 2 into fy given x equal to 2 of y plus px of 3 into fy given x equal to 3 of y. So this is nothing but the probability, since this is a uniform distribution, that is nothing but 1 by 3. So this is nothing but exponential 1, that is e to the power of minus y plus, again px of 2 is 1 by 3 into exponential 2 is 2 e to the power of minus 2y plus, this is 1 by 3 into normal 0,4, that is nothing but e to the power of minus y square divided by 8 all divided by 2 into root 2 pi. Okay, upon simplifying we'll have, I can take 1 by 3 as common, so what is remaining inside, e to the power of minus y plus 2 e to the power of minus 2y plus e to the power of minus y square divided by 8 all divided by 2 into root 2 pi, so which is nothing but the second option. Okay, so next question, so x is uniform 1 2, y given x equal to 1 is exponential 2, and y given x equal to is exponential 4. So we have to find the value of fx given y is equal to 3 of 2. Okay, so first of all let's find out the marginal of y. Fy of y is nothing but px of 1 into fy given x equal to 1 of y plus px of 2 into fy given x equal to 2 of y, so which is nothing but, what is this probability, uniform to elements, that is 1 by 2 into what is this function? This is nothing but exponential 2, that is 2 e to the power of minus 2y plus, now this is again 1 by 2 into what is this guy? This guy is again exponential of 4, that is 4 e to the power of minus 4y. So which is nothing but 2 will be cancelled, 2 1 times and 2 2 times, so that is nothing but e to the power of minus 2y plus 2 e to the power of minus 4y. Okay, so this is the marginal of y. So what about the conditional probability given? If x given y equal to 3 of 2, which is nothing but probability of x of 2 into f y given x equal to 2 of 3 whole divided by fy of 3. Okay, so which is nothing but 1 by 2 into 4 e to the power of minus 4y whole divided by e to the power of minus 2 into 3 plus 2 e to the power of minus 4 into 3. So this is not y, this is 3. So upon simplifying we'll have 2 e to the power of minus 12 whole divided by e to the power of minus 6 plus 2 e to the power of minus 12. So which is the first option. Okay, so the next question, the joint density function of two continuous random variable x and y is given as, okay, kxy, x is 0 to 4 and y is 0 to 1. Find the value of k, insert your answer in 2 decimal places. So how can we answer this? So we know that the entire differentiation of CDF, from CDF 0 to minus infinity to infinity will be 1. So which is nothing but integral minus infinity to infinity, again integral minus infinity to infinity of fxy of x comma y dx dy is equal to 1. So which is nothing but integral, what is the range for y, that is 0 to 1, again integral what is the range for x, that is 0 to 4, what is the function kxy dx dy is equal to 1. So let's integrate this guy first. So what is remaining, integral 0 to 1 is as it is. So what is ky is constant. So what is the integration of x, that is x square by 2, what are the limits, 0 to 4 dy. Okay, now this is nothing but 0 to 1 integral ky into, I'll take 1 by 2 outside, kx square, 4 square is 16, 0 is 0, so that is 16 by 2, I'll take it as outside, that is ky dy. Right, so that should be equal to 1, this should be equal to 1, and now 16 by 2 is 8, integral of, again k is outside, let's take k as outside, what is integral of y, y is again y square by 2, what are the limits, 0 to 1 is equal to 1, so I'll just write it here. So 8 4k of 1 minus 0 is equal to 1, so k is equal to 1 by 4, so which is nothing but 0.25. Okay, next question. So xy is uniform of D where D is equal to x comma y of x plus y less than 4 and x and y are greater than 0. Find the value of probability 2x plus y. So this question will be very easy if we try to solve it graphically. Okay, so now I'll just attempt to draw this graph here. Okay, 0 1 2 3 and let's say 4 1 2 3 and 4, Okay, let's try to plot this particular thing. What is this? X plus y, let's consider 4. So if x is 0, what happens to y? Y is equal to 4. And if y is equal to 0, what happens to x? X is 4. So these are the 2 points that we have. 0 comma 4 is this guy, and 4 comma 0 is this guy. I'll just use another pen. Okay, so now this is our line. So what is this? Plus x plus y less than 4 is nothing but all this area, right? Okay, so what about this guy? 2x plus y is equal to, what about this one? So if x is equal to 0, y is equal to 2, and if y is equal to 0, x is equal to 1. So now let's mark this point. 0 comma 2 is this guy, and 1 comma 0 is this point. And what about this one? Okay, so this is our other line. So what do we have to find out? 2x plus y should be greater than this one. So it means that our point of reference is, we have to find out the probability of this particular region, or the area of this particular region, right? So how to find out this? So to find out this particular area, this is a random quadrilateral. It will be difficult. So what shall we do? We shall calculate this particular area, and we'll subtract this particular area. So let's write it out down. How do we find that? So probability of 2x plus y greater than 2 is equal to 1 minus, okay, let's calculate the area of bigger triangle, that is half into, what is the base? Base is 4, height is again 4, which is nothing but 4 into 2 is 8 units. And what about this particular guy? That is half into, what is the base? 1, what is the height? 2, that is nothing again 1. Okay, so which is nothing but 1 minus probability of 2x plus y less than or equal to 2, right? So in this whole area we have to subtract this particular guy. I'm sorry, not this area, in the total entire solution, this particular area, that the bigger triangle, is nothing but the d, right? So now this is nothing but 1 minus, what is the probability of this? This has, in the entirety of d, it has only this, that is nothing but 1 over 8. Again, that is nothing but, this simplifies to 7 over 8. Okay, next question. So we have a joint density function of random variables x and y. So what do we have to find out? We have to find out p of x plus y is less than 1. Again, let's make use of graph. So what happens here? If x is 0, y is 1, and if y is 0, x is 1. So this particular line, so it is less than 1. So this is our desired region. So how to find out this? We simply can integrate this particular function. So what happens? We know the ranges. So integral 0 to 1, this is for y, and integral 0 to 1, this is for x. What is the function? X plus y. So this is not 1. So this is 1 minus y, because x plus y is equal to 1, right? Into dx. So this is nothing but integral 0 to 1. What is integral of x? That is x square by 2 plus y into x. What are the limits? That is 0 to 1 minus y dx. So this is nothing but integral 0 to 1 minus y the whole square, whole divided by 2 plus y into 1 minus y into dx. Sorry, this is dy. So So this is dx dy, so this is dy and this is also dy, so which is equal to integral 0 to 1. So if we expand this, I'll have 1 by 2 plus y square by 2 minus y plus, so if I multiply here, I'll have plus y minus y square of dy. So for the simplification, we'll have integral 0 to 1 by 2 minus y square by 2 into dy, so which is nothing but, if I integrate here, again we'll have y by 2 minus y cube by 3 into 2 is 6. So what are the limits? 0 to 1, so which is nothing but 1 by 2 minus 1 by 6. So the answer is 2 by 6, that is equal to 1 by 3. Okay, next question. So joint PDF of two continuous random variables x and y is given as some function. So we know the ranges. What is the marginal PDF of x? So how to find out the marginal PDF of x? So we have fx of x is nothing but integral with respect to y, right? So what is the range for y? 0 to 1. What is the function? 2 by 7 into 5x plus 2y into dy. Okay, so let's take out 2 by 7 outside. What is remaining? Integral 0 to 1 5x plus 2y of dy, which is equal to 2 by 7 into integral of 5x is nothing but 5 by 2 into x square plus integral of 2y, sorry, so this is nothing but 5xy because we are integrating with respect to y, and here we have y square. What are the limits? 0 to 1, so which is equal to 2 by 7 into 5x, because we have 1, right? So plus 1. So this is the marginal PDF. So this is the answer. So next question. Let x and y be jointly continuous random variables with joint PDM. We have one particular function. We have to find out the marginal of y. So obviously, to find out the marginal of y, first we have to find out the value of k. How to find out the value of k? We simply have to double integrate this given function, right? So what is the range of y now? 0 to 1. What is the range of x? That is 0 to 4. The function, that is k into 2 minus y, firstly dx, then dy, that should be equal to 1. So integral 0 to 1, what is the differentiation of this guy? If we take out k outside, I'll keep k here. 2 minus y is there. With respect to x, that is 2x minus yx. What are the limits? Limits are 0 to 4, dy is equal to 1. Again k into integral 0 to 1. If I add 4 here, 4 into 2 is 8 minus 4y into dy is equal to 1. So again k into integral is 8y minus 4y square divided by 2, that is 2y square. What are the limits? 0 to 1 equal to 1. Again we have k of 8 minus 2 is equal to 1. Again k is equal to 1 by 6. Okay, using this, again I'll have to integrate the function one time with respect to y, because we are, sorry, with respect to x, because they are asking the PDF of y. So the range of x is 0 to 4. What is the function? That is 1 by 6 into 2 minus y into dx, correct? So that is nothing but 1 by 6 will be outside, and I'll have 2x minus xy. What are the limits? 0 to 4. So 1 by 6 into 2 into 4 is 8 minus 4y. Okay, so now 8 minus 4y all divided by 6. I can simplify this as 4 minus 2y divided by 3. Finally, have the next question. Question 9. So they've given x and y as two independent continuous random variables with PDFs fx of x and fy of y as. So they have given the individual PMFs. So what we have to find out the probability of 2x plus y is greater than 1. Okay, so now how to do this? Starting with, let's plot a graph so it will be very easy for us to visualize. So what about two x plus y is equal to 1? So which is, I'll take 0, 1, and I'll take this as 2. Similarly 1, and I'll take this as 2. Okay, 2x plus y is equal to 1. Let's say if x is 0, y is equal to 1, and if y is equal to 0, x equal to 1 by 2. That is 1 by 2, and 0 is here, and 0 and y is here, so this particular line. Okay, so now what? What are the ranges of y? Y is the greater than and less than 2, so y will be less than 2 here. Okay, what about x? X is greater than or equal to 0, so in this particular direction, and now it is less than 1 in here. This will be the limit of x and y. So this is the region where we need to find out the variable, right? Since this is greater than symbol is given, so this is the desired region. Okay, so they have given this as independent, so what shall we do? We shall find out fxy of x comma y is nothing but fx of x into fy of y, which is nothing but 1 into y by 2, this guy and this guy, so which is equal to y by 2. So now probability of 2x plus y greater than 1 is equal to integral 0 to 1. This is the region for because we have greater than 1 here, and integral 0 to, this is for x, that is 1 minus y whole divided by 2. I'll just write it in a better way, 1 minus y whole divided by 2. This is the limit. See, okay, so now next, what is the function? That is y by 2 dx dy, so which is nothing but integral 0 to 1. So if I integrate this, what will I get? I'll have y by 2 into x, what is the limit? 0 to 1 minus y whole divided by 2 dy, so which is equal to integral 0 to 1 y by 2 of 1 minus y whole divided by 2 into dy, so which is equal to, I'll take 2 into 2 is 4, I'll take 1 by 4 outside, integral 0 to 1, I'll have y minus y square dy. Okay, if I integrate this again, I will have 1 by 4 into y square by 2 minus y cube by 3. The limits are 0 to 1, so which is equal to 1 by 4 into 1 by 2 minus 1 by 3, and again that is equal to 1 by 24. I'm sorry, this is not greater than 1, this is less than or equal to 1. This particular region is the probability of this particular region, the area of this particular region is this guy. So how to find out this probability of 2x plus y greater than 1 is nothing but 1 minus probability of 2x plus y less than or equal to 1. So that is nothing but 1 minus 1 by 24, which is nothing but 23 by 24. So next question. Joint density function of two random variables x and y is given as fxy is 8xy. Then we have the ranges for x and y. Are x and y independent? So how to find out whether these two guys are independent or not? We shall find out the marginal PMFs of each individual x and y. Fx of x is nothing but integral with respect to y. That is nothing but, what is the range for y? 0 to small x of 8xy dy. That is nothing but 8x. We'll take it outside. What is integration of y square? That is y square by 2. The limits are 0 to x to 1 times and to 4 times. That is 4x of x square minus 0. That is 4x cube. Right. So now marginal of y, fy of y is nothing but integral with respect to x. That is x limits are 0 to 1. 8xy into dx. That is nothing but 8y outside. We'll have x square by 2. Limits are 0 to 1, 1 time, 1 4 time. So we have 4y into 1 minus 0. That is nothing but 4y. What is fx of x into fy of y, which is nothing but 4x cube into 4y, which is equal to 16x cube y, which is not equal to fxy of x comma y. So obviously these two are not independent. Let x comma y is this uniform of d, where it is 3 comma 5 into 2 comma 4. Are x and y independent? Again, we shall use plot this particular region. What do we have here? Let's say this is 3 and 4 and 5, and let's say this is 2, 3 and 4. So what is happening here? Right, so this is our area of interest, right? So this is the D. Okay, so now what is the fxy of x comma y joint distribution? That is nothing but 1 by 4. Remember, the area of this guy is 2 into 2, that is 4. 1 by 4 wherever x comma y belongs to D, and now 0 otherwise. Okay, so now if I want to find out fx of x, which is nothing but integral 0 to, so what is the range for y? Y is 2 comma 4, right? Integral 2 to 4, that is 1 by 4 of dy, which is nothing but 1 by 4 into y of 0 to 4, that is 1 by 4 into 4 minus 2 is 2, that is 1 by 2. And now what is fy of y, which is nothing but the range of x is 3 to 5. Integral 3 to 5, 1 by 4 dx, so that is nothing but 1 by 4 into 5 minus 3, that is nothing but 1 by 2. So what about fx into fy? Fx of x into fy of y, which is equal to 1 by 2 into 1 by 2, that is nothing but 1 by 4, and that is again equal to fxy of x comma y. So therefore we can say that these two random variables are independent. Okay, next question. The joint PDF of two random variable x and y is given. Okay, so we have to find out x given y is equal to 0.5. So okay, so how to do this? So firstly we'll find out the marginal of y. Fy of 0 is nothing but integral of x ranges 0 to 1. We have 4xy of dx, and that is equal to 4y outside. We'll have x square by 2, limits are 0 1. We have 1 time and 2 time 2y of 1 minus 0, that is nothing but 2y. Okay, now what is fy of 0.5? That is nothing but 2 into 1 by 2, that is nothing but 1. Okay, now fx of fx given y is equal to 0.5 of 2, which is nothing but fxy of 2 comma 0.5 whole divided by, sorry, this is not 2, this is x. Okay, x comma 0.5 divided by fy of 0.5. So this is nothing but, what is the function here? 4xy. So that is nothing but 4x as it is, and this is 1 by 2 whole divided by 1, so which is nothing but 2x. So first option is the right one. Okay, next one. The joint PDF of two random variables x and y is given. So find the value of p 1 by 4 less than x less than 1 by 2 given y is equal to 1. So again, similar to the previous problem, firstly we have to find out the marginal of y. Fy of y is nothing but integral, range of x is 0 to 1, function is x square plus xy whole divided by 3 into dx. So again that is equal to x cube by 3 plus x square y by 6. What are the limits? That is 0 and 1, which is equal to 1 by 3 plus y 1 by 3 plus y by 6. Okay, now what is fy of 1? Fy of 1 is nothing but 1 by 3 plus 1 by 6, which is equal to 3 by 6, and now that is again equal to 1 by 2. Okay, now what is f of fx given y is equal to 1 of x? And now this is equal to fxy of x comma 1 whole divided by fy of 1, so which is equal to the function in this we have to substitute y as 1, that is x square plus x by 3 whole divided by 1 by 2. This is nothing but 2 of x square plus x by 3. Now in this particular thing we'll have to apply the range for x, that is 1 by 4 less than x less than 1 by 2 given y is equal to 1 is nothing but integral minus 1 by 4 to 1 by 2 of this particular guy, that is 2 into x square plus x by 3 dx, now which is equal to 2. I'll take it outside, and if I integrate the x square I'll get x cube by 3 plus x square by 6. The limits are 1 by 4 to 1 by 2. Now this is nothing but, I'll write in the next line, okay, which is equal to 2 into, and I'll take 1.3 outside. What is x cube? 1 by 2 cube is 1 by 8 minus 1 by 4 cube, that is 1 by 64. Okay, again plus, I'll take 1 by 6 outside, 1 by 6 of x square, that is 1 by 4 minus 1 by 4 whole square, that is 1 by 16. So again this, if I simplify it, again I'll have 2 of, I'll take the LCM as 1 by 64, 64 is the LCM, I'll have 8 here minus 1 plus 1 by 6, and I'll have 16 as the LCM, and it's 4 minus 1, and now the answer is 2 over 7 by 3 into 64 is again 192 plus 6 into 16 is 3 by 96. So the answer is 13 by 96 is the answer. Okay, next one. Okay, finally we have finished with this. Thank you for watching. Hope you have benefited from this. Consider like, sharing and subscribing. Thank you.